Welcome to IB Chemistry exam preparation, exam tips for both standard level and higher level. Today we're going to cover topic 8, acids and bases. We will answer practice questions on paper 1 for standard level. So let's get started. Starting with the first question. Which ion are present in an aqueous solution of sodium carbonate? When we want to answer these questions, we need to look at the choices. But the first thing, we need to remember that this salt inside solution, it will split into sodium ion and there will be also the carbonate ion as well. And when we want to take the carbonate ion, we need to further remember that this carbonate ion inside water, it will behave as a base, so it will be a proton acceptor, and this will form HCO3 negative plus OH negative. So going back to the question, we're going to find that the ions that are represented will be all of the above. There will be hydrogen carbonate ion, hydroxide ion as well will appear besides the carbonate ion. So the answer, it's a D answer. Continuing with question number 2, what is the conjugate acid of hydrogen sulfide ion? If the question is asking you to find out the conjugate acid, definitely you need to add H positive. So if you add H positive to the HS negative, your final answer would be A, which is H2S, which is amphiprotic. So we need to look at the species that can behave as both acid and base according to a Bronsted-Lowry definition. So it is a proton donor and it is a proton acceptor at the same time. If you look at the choices, you're going to find that the answer is water. Since the water, if it behaves as an acid, this will form OH negative. And if it behaves as a base, so it can accept a hydrogen and this will form hydronium ion. Continuing with question number 4, which solution has a pH of 9? Here we need to remember that the rule of the pH is negative logarithm the concentration of hydrogen ion. Starting with A. We have 1 times 10 to the power of negative 9 mole of the HCl. So if I want to calculate the pH, I'm going to find that it is negative logarithm 1 times 10 to the power of negative 9. And since I have a 1, so definitely the power, it will be the pH. So the pH equals in this situation 9. But I cannot circle this answer, taking into situation that the hydrochloric acid is an acid actually. So this is incorrect statement from the beginning part. We cannot have an acid with a pH of 9. So when the question is asking me to find the pH of 9, I need to remember that I'm looking for a base actually. So since I'm looking for a base, I'm not going to choose A or even D. Continuing with the other two choices, you're going to find that the answer is, continuing with the second, you have 1 times 10 to the power of negative 5 of KOH. So the first step is to calculate the POH value since you are talking about a base. So the POH is negative the logarithm of the 1 times 10 to the power of negative 5. So the answer, it will be a 5. Continuing with the pH, remember that the rule, pH equal 14 minus 5, and your final answer is 9. So the answer, it is definitely the B answer. So here remember to choose the base, then remember to calculate the POH value, then to find out the pH value. Continuing with question number 5, which cannot act as a Bronsted-Lowry base? What is the definition of a Bronsted-Lowry base? It is a proton acceptor. So it cannot behave as a proton acceptor. Starting with A, it can, since I can add hydrogen ion. And the B, yes, it can. It can form H3O+, which is the hydronium ion. But looking at the CH4, I cannot find a molecule in chemistry which is CH5. So this is not presented. So methane in this situation, it's not actually a Bronsted-Lowry base at all. Continuing with question number 6. Which causes acid deposition? So I'm talking about the acid rain. Here we need to remember that the acid rain is caused by the sulfur dioxide as a gas. It's not allowed to choose the carbon dioxide since it is presented in nature. Question number 7. Which substance will not produce copper 2 chloride when added to dilute hydrochloric acid? So I'm thinking here of adding hydrochloric acid to each of A, B, C. I need to think which one will not react to the hydrochloric acid. The hydrochloric acid is actually an acid-base chemical reaction here is taking place. So if I want to start with the first situation, the copper here, it's a metal. In order to have a chemical reaction, the copper should replace the hydrogen in order to form the copper chloride. So if I'm going to consider here the chemical reaction, this will produce copper chloride and hydrogen. But this chemical reaction will not take place if the copper was not more reactive than the hydrogen. The copper here is less reactive. The point that I'm going to mention here, this question, which is question number 7, it is also integrated with chapter number 9, which is talking about redox reaction. So I need to go back to the reactivity series and to compare the reactivity. So in this situation, I cannot have a reaction between the copper and between the hydrochloric acid. So there is no reaction. And as I said previously, you will be familiar on such these questions if you apply on chapter number 9. But continuing with the other choices, if you look at the copper hydroxide, it's a base. It may react definitely with an acid, so this will form salt and water. So there will be a production of copper chloride plus water molecule. The same situation for the second, so this will also form copper chloride plus the H2O. And finally, there will be also here copper chloride, and there will be carbon dioxide beside having the H2O. So the only choice is the A, which will not react, as the copper is less reactive than the hydrogen. So the single replacement reaction will not take place. And this is another time related to chapter 9 besides the acid bases. What is the difference between a conjugate Bronsted-Lowry acid-base pair? So we need here to remember what's the major difference between both. Is it electron pair? Is it the positive charge? Is it the proton? Or is it finally the hydrogen atom? So definitely the answer is proton, which stands for the hydrogen ion. So the difference between the Bronsted-Lowry acid-base pair is in the hydrogen ion, which would be presented in case of the conjugate base. 9, which is an example of amphiprotic species. So another time we need to remember that we are talking about a species that can behave as an acid or a base based on the Bronsted-Lowry definition. If we look at the choices, aluminum oxide is actually an amphitoric species. It behaves as an acid base, but it's not amphiprotic. There is no proton donor and proton acceptor. Going through the choices, which one can donate and at the same time can accept? It's the D answer. It can accept forming H2PO4, or it can donate in order to form PO4 -3. Continuing with 10, which solution is basic at 25? So here we need to remember that we are looking for a pH which is higher than 7 for the basicity. Starting with A, the pH for A, it is 3, which is the power presented right here. For the B, we need firstly to find out the pOH, which is 13. Continuing with the pH, it is 14 minus 13, which is equal to 1. So this is acidic, it's not basic. So this is incorrect answer as well. Solution of a pH of 4, it is of course acidic. Finally, we have the last one, the pH here. It's equal to 13. This is above 7, so definitely this is my base. So the answer, it's a D answer. Question number 11, which is not a source of oxide of sulfur and nitrogen. So here we are talking about the acid deposition and the pollution another time. Which one is not a source? Burning coal, it will produce for me the sulfur dioxide. Internal combustion engine, it will produce for me the nitrogen oxide gases. Burning methane, it produces carbon dioxide and water. Volcanic eruption, it causes to form the sulfur dioxide. So which one is not a source? It is definitely the burning of methane. Continuing with question number 12. What is the pH of 0.01 molarity KOH? So remember that this is a base. So definitely I'm going to start with the pOH, which is minus log the 0.01, which equals to minus log the 1 times 10 to the power of negative 2. So your final answer, it's a 2. Continuing with the pH, which is 14 minus 2, and your final answer is 12. So it's a C answer. What is the correct for pure hot water? We need to remember that for any hot water, cold water, or any other type of water, no matter what is the temperature, since it's a pure, so definitely the concentration of hydrogen ion should equal to the concentration of OH negative. They will never change. So it's not C and it's not D as well. I'm going either to pick A or B. Continuing with the pH. The pH, it will not be exactly at all. It could be also D, so I'm going also to think about it since it is hydrogen ion, which is equal to OH negative. So it's not C definitely. It's not exactly 7 since it is hot. Here we need to refer to the effect of temperature on the kW value. So if the temperature increases, we need here to remember that the kW, it will increase. Since referring back to the decomposition of water, which is the autoionization that causes to form for me both OH negative and hydroxide ion. So kW will equal the concentration of the hydrogen ion multiplied by the OH negative. Since this reaction is endothermic, so the energy is part from the reactants. So when the temperature increases, the chemical equilibrium will shift to the right. So this causes to increase the kW. So the relationship here between the T and between the kW, it is directly proportional. So going back another time to the question. So if the T increases, kW will increase. Both H positive and OH negative, both of them, they will also increase, but they will increase in the same amount. Because of that, they will stay equal, so they will not change. So now the point is, what happens exactly for the pH? If the kW increases, here we need to remember that the pKW, which is the logarithm, it will decrease. So based on that, the pH of the water, it will be below 7. So the number will be smaller than 7, as if, for example, 6 plus 6 becomes 12, or 5 plus 5 becomes 10, no matter what is the number. But when it is a hot water, it will be as a pH lower than 7. And at the same situation, also the pOH will be lower than 7. So increasing the temperature causes the H positive to increase, and at the same time the pH will definitely decrease, but it will not be acidic. It will stay as a neutral. Continuing with question number 14, which of these oxides contribute to acid deposition? Another time, my answer is SO2 is a correct answer. NO2 is another correct answer. It's not allowed for you to choose the carbon dioxide, since as we know previously, this is presented in nature, so we're not going to take it as an acid deposition. So your answer is 1 and 2. Continuing with 15, what is the pH of ammonia that has a concentration of OH negative 1 times 10 to the power of negative 4? So we can start with the pOH, which is equal to negative logarithm 1 times 10 to the power of negative 4. So your answer is 4. Continuing with the pH, which is 10 minus, which is 14 minus 10 minus 4, and your final answer, it's a 10. So it is definitely the C answer. Continuing with 16, consider the equilibrium below. Which species represent a conjugate acid-base pair? So we're going to look for the conjugate acid-base pair. Starting with the propanoic acid, it turns into propanate. So this is an acid, it's a proton donor. This one is the conjugate base for the acid. This behaves as a base, it's a proton acceptor, and this is the conjugate acid. So where is my conjugate acid-base pair? It is the hydronium ion and the water as well. Continuing with question 17, in which equilibria are the conjugate acid-base pairs correctly labeled? So let's start with the first situation. Carbonate ion turns into HCO3 negative, so this is a proton acceptor, so this is a base. That's right. So this would be the conjugate acid, so it's an acid, and definitely this is the acid, and this is the conjugate base, so this is a correct labeling. Continuing with double I, HCO3 negative turns into H2CO3, so this is another time a proton acceptor. It accepts the proton, so this is of course a base. This is my acid, this is the conjugate acid, and this is the base, so another time the label is correct. Ammonium ion, it turns into ammonia, so this is a proton donor, so this is an acid, it donates H positive, so this is its conjugate base, this is the base, and this is the conjugate acid, so yes, another time it is also correct. So the final answer is all of the above. A solution of acid HX has a pH equals 1, and a solution of acid HY has a pH which is equal to 3. Which statement must be correct? And I will underline the word of must here. If I'm going to start thinking about the options, there is a very important tip here. If the question is asking to compare between two pHs, make sure to look at the hydrogen ions inside your answer, as how many times it is larger. I cannot say that either A or B is correct. Why is that? If I want to read A, HX is a stronger acid. Is it a correct statement as a must? I cannot say that it's 100%. Why? I can take vinegar, for example, which is considered a weak acid, and I can prepare from this weak acid a pH of 1. I can add a very large amount of the vinegar in a small amount of water, and at the end I can prepare a pH of 1. So I cannot say at all that this is a must. It's not always a correct answer. So it's not A. So continuing with C and D, the hydrogen ion in the solution of HX is 100 times greater than the hydrogen ion in the solution of HY. This is a correct answer. Why is that? If you want to compare between the pH 1 and pH 3, so there is a 100 times difference in the hydrogen ion concentration. And here we need to remember that the pH of 1, it has higher acidity. So definitely it is 100 times greater than the concentration of hydrogen ion in the HY. Remember that according to the pH scale, the difference between one number and another is a 10. So if this is a 10, this is a 10. In total, this is considered as being 100 times different. Continuing now with question number 19. The values of the Kw of ionic product constant of water are, we have the Kw which are 6.4 times 10 to the power of negative 15 and the temperature is 18. We have also 1 times 10 to the power of negative 14 and the temperature is 25. So we can find that if the temperature increases, the Kw also increases. And of course, we remember that the H positive also increases, the OH negative also increases, but both of them, they will have exactly the same values. All of these tips should be inside your mind anytime we are talking about the Kw. So let's start reading. Which statement are correct? The hydrogen ion concentration or the hydroxide ion in water is less. It's not. Of course, for pure water, no matter what's the temperature into which we are considering, both should have the same exactly concentration. So this is incorrect answer. The ionization of water is an endothermic reaction. So if you remember, the chemical balanced equation is water that splits into H positive plus OH negative. Is the ionization endothermic? Yes, it is. Remember that this is a decomposition reaction. So yes, it is an endothermic. This is decomposition reaction. Continuing with the pH. The pH of water is lower at 25 than at 18. Yes, that's right. When the temperature increases, the H positive will increase and the pH will definitely decrease. So this is a correct answer. This is another correct answer. And your final answer, it is C, which is 2 and 3 together. Now we have question number 20. A student has equal volumes of 1 mole per decimeter cube sodium hydroxide, which is NaOH. Remember that this is a strong base. And we have ammonia, which is NH3, which is considered a weak base. Which statement about solutions is correct? If I'm going now to start, sodium hydroxide has a lower electrical conductivity. Of course, no, since it's stronger, so it is higher. Sodium hydroxide has a higher hydrogen ion concentration than ammonia. Sodium hydroxide has a higher pH. Yes, that's right. The pH of the sodium hydroxide, it is definitely higher than the ammonia since it has a stronger pH, or it is considered as being stronger base. Now we have the last question. With which do most acids react? Remember, when we are talking about acids, acids all react with metals and they definitely react with bases. And when we want to talk about base, it could be base with a hydroxide, or it could be with an oxide, or it could be with the carbonate. These are the 3 different situations of bases. As a metal hydroxide, metal oxide, or we have metal carbonate. For example, NaOH or Na2O, or we have the NaCO3, or even the sodium hydrogen carbonate. So let's go to the options. Sodium hydrogen carbonate, definitely it is one of the accepted answers, so acids will react with it. Magnesium, another time, yes, it will react with it as a metal. Finally, calcium sulfate, this is a salt. The acids do not react with a salt. So in this situation, we're going to pick 1 and 2, and your final answer is 1 and 2 only. So we are till now done with the multiple choices, and we're going to continue later with some practice exercises, questions considering paper 2.